Hey, this is Doug Mann here. Wanted to explain this Thingiverse print file that I have listed. This is an actual Bedini SG device, SG Energizer. It's not particularly used for the actual motoring effect that you'll see here. There's not a whole lot of torque involved with it. But the main thing with this particular device here is to study the spike energy that comes from the collapse of the coil. This particular device here, I started out, you'll see this file here with the bare open magnet design. I had some issues with that, even with giving a full coverage of super glue and on those three sides. My wheel wasn't balanced real good, and I'd actually have magnets flying off at 2400 RPMs. So you can use that. I'm sure there's some adhesives out there that hold really well. The white Gorilla Glue, I've tested on one of the magnets, and that does hold up really well. It's got a really good expansion and holds it in place. But if you don't want to mess with doing that and you want, a safer design, I did put a design up there to enclose the magnets. On top of that, I also got these end caps that have pulleys for any future development you want to do to use any of that little bit of available torque with this particular setup. This particular design here uses a really big coil. If you get the Bedini SG series book, it goes a little bit more into detail about coils. This here is going to be a little bit more of an advanced design once you get to involved with this technology to learn about it. This may be something you want to do down the road. Just starting out, this is one of the first Bedini SGs I did. This is a little closer to the original design that was put out there. This particular size coil, this is about a 2-inch tall coil, and it's about a 1.5 inch thick. And the core material for this particular one, I use these little rods I got from Harbor Freight. They actually came in a roll, and I just pre-cut them and put them in the middle and super glued them in place, and that worked as the actual core. You can use that with this bigger design to put them in the middle. Or you can go with, I use this number 8 steel shot that's used to reload shotguns. This was explained on the actual energy science side on one of the videos that's related there. You could probably find it. It's basically, it's just a bunch of painted number 8 steel shot, like I just said, and painted with some primer, and that keeps it electrically separate. And I just put some of that in the middle and just use an adhesive. You can use probably a polyester type adhesive or super glue, or maybe even some resin if you want to pour that down in there. Would probably be the best option, the sturdiest. But that's pretty much it. As far as the circuit here, I've got 7 available power wires, and I'm only using 2 with this particular circuit. I'm using 2 small transistors, 2 tip 41C transistors. I'm using a ½ watt worth of 470 ohm resistors, and I'm using the 1N 4001 2 diodes and 2 1N 4007 diodes. If you get the Bedini SG series book, it goes more into detail about that particular circuit as well. I'm not going to go into a whole lot of detail here, but you can check out the site if you want to learn more about that. For the batteries here, I've got these garden batteries. They're 12 volt. I've got the front one here is running, and I've got the back one here is capturing that spike energy that's coming off the output of the system. And you'll actually see, I'll show you that it's actually raising the potential of that charge battery that's in the back. A lot of you that have been in this for a while know all about this and probably know a little bit more in detail than I do. You can actually do a Google search or search YouTube videos, and you'll probably find somebody that has an oscilloscope that's hooked up, and you can actually see that spike energy that's coming off the collapse of that coil. I don't have that set up. I just basically wanted to show the actual device here and show that it works. And I'm gonna do a RPM test here too to show it spinning with just those 2 small transistors hooked up. This is the charge battery. I just have this multimeter hooked up to. You can see the resting voltage here is 12.36. Up a little closer. 12.36. I'm going to go ahead and put this reflective strip on the rotor as well, and you can see that I need that to measure the speed. I haven't actually measured the speed on this particular rotor yet. The other one got up to 24,077, and that was on a really unbalanced rotor. This one's really not balanced precision either, but the bearings are better, and I believe it's gonna get a few more RPMs out of it maybe. It takes a while for it to get up to full speed, but we'll show it anyway. You'll hear a little bump when I hook the primary battery up, and that lets you know that the circuit's good. And you'll have to even give it a good spin, because when the magnets pass by, for you, those of you that are new, that induction on that trigger wire causes the transistor to turn on each time that the magnet passes by that coil core. You can see here the voltage is already starting to raise up on that charged battery. It may drop a little bit about midway, and then once it gets up to full speed, it'll start rising constantly. On this small setup here, I've only got a charged battery up to like 12.75 or so, and it takes it a while to get there on this small setup. I don't know if you can hear it or not, but it's gradually increasing in speed. If you get the Bedini SG series book, it goes into explanation on how you can hook up a discharge circuit on the back that allows the spike energy to collect in the capacitor, and it releases bursts of energy into that charged battery. That's a little more beneficial to charge the actual battery. I'm just running that radiant spike to the actual charged battery, and it's more of a fluffy charge. So it's going to take a lot longer to give you a good charge on that battery than it would be with that capacitive just discharge circuit. If you're not real familiar with the circuitry on how to put together the circuits and so forth, there's plenty of information online. If you want a pre-built circuit, there's a company called TeslaGenics.com that actually sells the circuits for these types of devices. It's still gradually gaining in speed. It's up to 1326 and gradually climbing. If you notice here on this device, you'll see a lot of that. I used the Gorilla Glue. When this happened, when I lost those two magnets there, I was not in the room when that happened. It's probably a good thing, but I heard the crash. When it actually lost those magnets, the whole device fell into the wood floor. And this is PLA. Everything here is made from PLA, which you can imagine that didn't go too well. So it fared pretty good for the fall. It was about a 3-foot drop to the floor. But I had to do use some Frankenstein techniques to get it back together. Still increasing in speed. up to 1546. You see the charge battery is at 1257. This front battery is kind of low. I've been running it for a while now. We can check that real quick. That front battery is down to 1208, 12.7, so it's pretty low. I would imagine if we had that fully charged, it'd be up and running a lot quicker. And it looks like maybe where that battery is at, it's only going to get up to this speed. It looks like maybe 1558. But even at that, it's still putting out the spikes. It's just raising the potential in that charged battery. That's it. That's all I really have to show you here. Obviously, if you have some questions, you can go to Energy Science, the Energy Science forum, hit the link, and you can comment and ask questions there.